Section 6.6 is entitled Similarity Transformation. So really this is just a continuation of all of the dilations that we did earlier in the chapter. So just as a reminder, a dilation is a transformation that stretches or shrinks a figure to create a similar figure. So this is exactly why a dilation is considered a similarity transformation, because you're creating a similar figure in the process. So therefore, once again, dilations can also be called similarity transformations. A figure is enlarged or reduced with respect to a fixed point called the center of dilation. The scale factor of a dilation is the ratio of a side length of the image, which is the new figure, to the corresponding side length of the original figure. So this is just reiterating that when you're doing a scale factor for a dilation or a similarity transformation, you always want to do new over old. Referring to this diagram, triangle XYZ is the image of triangle ABC. The center of dilation is 0, 0, which is the origin, and the scale factor would be found by taking corresponding sides over each other. So you could use XY over AB. You could also do XZ over AC or YZ over BC, because remember, you should always do new over old. So here's a key concept that would be nice to have in your notes: the coordinate notation for a dilation. And we saw this in our homework a couple sections ago. You can describe a dilation with respect to the origin with the notation of XY becomes kx, ky, where k is the scale factor. So remember, that just means that I'm multiplying by some number to either make the figure bigger or smaller. If k is a number between 0 and 1, so like a fraction, maybe 1/2, the dilation is a reduction, meaning that the new figure would be smaller than the old figure. If the k value is greater than 1, then the dilation is an enlargement, meaning that the new figure would be bigger than the old figure. Now let's look at an example. So here's number 1. Find the vertices of FGHJ, which is the image of ABCD, after a dilation with a scale factor of 1.5, and vertices A, 2, 2, B, 4, 2, C, 4, 0, and D, 0, negative 2. To do this, all we're going to do is take the vertices of ABCD and take both the x and the y values times 1.5, the scale factor. So let's first take the 2, 2, and we're just going to take each number times 1.5. 2 times 1.5 is 3, so I'd get 3, 3 for F. Then I'm going to take the coordinates of B, 4, 2, and multiply each number times 1.5. 4 times 1.5 is 6, and 2 times 1.5 is 3. So the coordinates of G would be 6, 3. Next, I'm going to take C, which is 4, 0, and take it times 1.5. So 4 times 1.5 is 6, and 0 times 1.5 is 0. Finally, we'll take D, which is 0, negative 2, times the 1.5 scale factor. 0 times 1.5 is still 0, and negative 2 times 1.5 would be negative 3. So all you're going to do is take each number times the scale factor. Here's another example. A triangle has vertices A, 2, 4, B, 8, 4, and C, 8, negative 4. The image of triangle ABC after a dilation of scale factor 1/2 is triangle DEF. Find the coordinates of DEF. So just like the last problem, we're just going to take each of the ordered pairs and multiply each number times 1/2. So A, which is at 2, 4, I'm basically just taking each number, I'm going to take half of it. So 2 divided by 2 is 1, and 4 divided by 2 is 2. Then I'm going to take B, 8, 4, take half of each of those. So 8 divided by 2 is 4, and 4 divided by 2 is 2. And then again for 8, negative 4, it would be 4, negative 2. Basically, you're just going to take each of the ordered pairs and multiply by the scale factor. Example number 3. You are using a photo quality printer to enlarge a digital picture. The picture on the computer screen is 6 centimeters by 6 centimeters. The printed image is 15 centimeters by 15 centimeters. What is the scale factor of the enlargement? So let's draw a picture. The original is 6 centimeters by 6 centimeters. The enlargement is 15 centimeters by 15 centimeters. And since I know that I'm enlarging the digital picture, I am going to have a scale factor bigger than 1. So that means I would take the new over the old. So in this case, it would be 15 over 6, which in lowest terms is 3 over 2. And we would probably want it just as a decimal, so we would have an enlargement of 1.5. So really, this means I'm enlarging it by 1.5 times its original picture. And just a side note about reading the diagrams. If the center of dilation is at the origin, then a point on the figure and its image lie on the same ray from the origin. So you can see here, since X would be the image of A ray connects those two coming straight out of the origin. Y corresponds to B, so a ray connecting those two comes straight out of the origin. And the same goes for Z and C. I can connect them with the ray coming from the origin. However, if a point on the figure is the origin, then its image is also the origin, since you would not be able to draw a ray to that image from the origin. And now on to our last example, number 4. You want to create a quadrilateral RSTU that is similar to quadrilateral ABCD. What are the coordinates of U? So what we need to first do is find the scale factor of the coordinates that we know. So if we look at A, it is at 1, 2. It corresponds to R, which is at 3, 6. Then we look at B. It is at 2, 1, and it corresponds to S, which is at 6, 3. And finally look at C, which is at 2, 0, and it corresponds to T, which is at 6, 0. So now looking back at our ordered pairs, we can see that we are taking each X and Y value and multiplying them by 3 in order to get the image RST. So again, we have 1 times 3 is 3, 2 times 3 is 6, 2 times 3 is 6, 1 times 3 is 3. 2 times 3 is 6, 0 times 3 is 0. So we have a scale factor of 3. So now we're going to apply that scale factor of 3 to the coordinates of D to find its image, which would be at U. So looking at the coordinates of D, it is at 5, 3. So taking that same scale factor, we would assume its image U would just be multiplied by 3. So 5 times 3 is 15, and 3 times 3 is 9. Since the question was, what are the coordinates of U? That is our final answer, so U is at 15, 9. That's it for this section. Make sure you jot down anything you don't understand that we can cover in class, and we'll see you then.